Hi, this is Merlin. Today I'm just gonna talk about what I learned today. So today the main topic is the sorting algorithm and tree algorithm. The first of all, I'm gonna show you the like normal part, like not advanced, the basic the sorting algorithm, which is bubble sorting, and insertion, and what else? Selection. Yeah. So that is kind of really basic of it. And first of all, the bubble is really simple. Bubble is just really. I'm just gonna show it to you. Let's say you have a 1, like here 4, 5, 6, 2, 9. Let's put 9 here. So the bubble, so what it just doing, it just switching, it just looping your arrays, and it just switching by pushing some kind of loop of it. So I'm just gonna like show it to you. You're 4. This is 4, and you have to compare with the 1. If the 4 is bigger than 1, and 1 has to go here. And next time, if the 4 is bigger than the 5, 4 is bigger than the 5, but it's not. It's keep here, and the 5 is smaller than 6, but 2 is smaller than 6. It has to be switched here like this. And next part, it has to be the looping again of it. It has to be loop again. Wait, hold on. Well, was it like this part? Wait. I'm just gonna look at my code. The bubble sort is basically so it's just looping. So it's just looping if there is this or not. So it's just looping. So basically, we already know that this value is already started, but the bubble sort, it doesn't care. But because this is still not sorted, so this bubble is doing like multiple of the loop that make sure that these two values has to be sorted in here. And that's gonna be really bad for the if there's like big data. Even though you already sorted, but if the value is not sorted, you have to use for loop of it. So that's gonna be the time complexity is all over n 2, and the minimal, the ideal, the time complexity is all n. So the reason why it takes like O squared 2 is because, like I just say, like I just talked to you, the number 2 has to be go in the next to 1, but to make sure this happens, it has to be executed inside the for loop of it. So that has to be like two for loops. So there's gonna be there's gonna be n squared 2, and also the idealized is value is n is because the 1 2 because it still has to be read the data to the end of the data. So there's kind of time complexity. And next, and that's kind of bubble thing. But bubble sorting algorithm is very simple. And next is insertion. So what is insertion is doing is, so insertion is basically basically you insert rather than you insert some kind of the value that has to be sorted into next to value. Example, there's 1 is pretty fine, there's no reset, and 4 is already wait, let's try to switch like this. So 165,429 is unsorted. So insertion sort is basically, okay, there's 6, okay, there's 5, but we just like insert like this, not change it, it just insert it like this. If it is 4, insert it like here. And if it is 2, you have to insert it on this part. So which means that you really have to know about this value to insert it. So that's gonna be the also the loop of it. Also, the insertion, the time complexity is also 1 O(n) square, on 2 square, because it has to be nested for loop of it, or the loop of it. And this, what I believe about selection is, wait, I'm just gonna look at the code of it. Oh yeah, so selection is basically getting the mean data. So you already have the minima data here, but starting for the here, your minima data, you put the loop of it, you put loop here, and you check this is the minima data. You already know this is minima data, and you have to change your base pointer, the 4 pointer, and you have to change it here. So example, this 2, okay, but the 4 has to be changed because that's the pointer of it, and that has to be changed like this. Like this part. And this also this part 5, 6, and the 4, and if it is 5 here, and this 4, and this is based, wait, hold on, I'm just gonna delete this part and this part, and the 4 is really smallest, and you select this part. This is the base pointer, and you know that the 4 is really smallest, and you change it like this. So that's kind of like simplify the selection sort. That's very fine, but all of these, the bubble insertion and selection is required what I believe is like O(n) squared of it. Wait, hold on, I'm just gonna check the time complexity of it. Algorithm, sorting algorithm. Yeah, what? Wait, hold on, I'm just gonna. Yeah, the bubble sort, the best time complexity O(n), the average time complexity O(n) 2 square, O(n) square 2, and insertion also same, but selection is selection is the best time complexity is O(n) square. The reason why O(n) square is, wait, I don't get why it's O(n) square. Here, hold on. So selection is basically checking some kind of data, some kind of it's 2 square, because the reason why selection is the best time complex O(n) square is because even though if it's rearranged, I'm just gonna give you an example of it. So let's see, this is already arranged. So you given this already arranged, but the selection means that it has to be compared even though it is already orange or not, because you don't know it is already shorted. So even though this 2 is already the minimal, is already next to the 1, and you still have to check it. Like check it. And if it's not, you go here and 4, check it, and there's gonna be more time complex of it. So the selection is not. It's kind of the ideal of the selection is to check the using pointer of it, but the best time complexity is the O(n) square. Yeah, that's absolutely correct. And next, the sorting is merge sort. So the merge sort is kind of advanced sorting, but it's not really hard of it. It just it's just making your tree, your array, as like splitting into some kind of 2 node. Your 1 4, it's just splitting your half of it, or making like this, like this. So compare this to make it say compare like this. Compare 1 and 4, and you check the 1 and 4, you sort the 1 and 4, and that's the 1 and 4, of course, and you see the 5 is 6. Oh, no, not this part. You have to split into half, and there should be 2 variable, which is 1 and 4 and 4 and 5. 1 and 4. One and 4 and 4 and 5. So based on that, you made some kind of this is kind of hard. Yeah, and it's gonna be split into 1 and 4 half, 4 5, 1 4 5, but this is already shorted. That's pretty nice. But if it is 6 and 2 and 9, like 2 and 9, like if it's like 6 2, like let's say line just 9 is just like separated here, and let's say like 1 and 2, 6 and 2 is here, 6 2 is here, and you have to short it here like this to 6, and you have to like merge it into this 6, and you have to short it, and you have to merge it 1 4 5, and you have to short F. You have to now merge the whole thing, and you have to short it. So there's gonna be 1 2 5 6 1 2. Yeah, I think that's gonna process, but I'm not sure about this. But it's very hard now. That's from the example of merge short. So this is merge short. So basically, you're splitting to half of it. Let's just say you're just splitting to half, make it merge and like make a compact of it. So that's kind of the process of merge short. And also the quick short is basically, hold on, I forgot. Yeah, quick short was just make this as a based make a based base pointer and check it. Wait, hold on, not this part. Quick short was like this. Make it like this here as the base, and change it like here. And by splitting the half, by based on this value, you check starting from here is starting from here. You check this value is shorted or not. After 1 is 4, and but after 2 isn't 6. So you stop it, and I believe I changed it like this. I'm sorry. I think I have to study again. Yeah, I think merge short and the quick short, and the, what was that? The heap short. I think I'm not good. Yeah, based on, if you look here, based on this part, based on the index you already defined, it's shorted and base here. And the heap short is just making us a heap. It's just tree based, and it has to be shorting from the top of it. So this is it. Have a nice day. Seeing this time. Bye bye.